Now, if you're sitting at home and you have a pocket calculator somewhere handy, get it out fast. Or a desk calculator, or if you've got a computer, plug it in quick. But do not use this screen to view upon. Why? Because you're about to see a young man who is a phenomenon. Right. But if you have your pocket calculators, you'll be able to join in, you see. Makes it more fun. Now, this is a computer. It's been housed, of course. I've got a monitor up here. And I'm going to join in as well on this microcomputer. Over here, we have 4 people taken from our audience at random. And I'm laughing because I've just seen the hat. I won't make any jokes about it. But you've got pocket calculators, and they're just normal, aren't they? They're the sort of little things that you get anywhere. And although we gave them to you, you've checked them, and that's all they are. Say yes, Paul.
Yes.
Good, very honest. And over here, we've got a blackboard, an early form of pocket calculator. Right on it. And what are these? 1, 2, 3, 4, 12 people tried, tested and true, I can't even say it, from our audience. And there's nobody stooge. You are really just sat there waiting to find out what's going to happen. Say yes, Paul. Good. I'll tell you what's going to happen. We have brought along to the studios tonight a young man who does incredible mental calculations. I shall say no more. I shall just leave you in the capable hands of, from USA, Arthur Benjamin. Welcome, Arthur. Like I said, it's over to you.
Good evening, ladies and gentlemen. My name is Arthur Benjamin, and this is Mathemagician. As Paul has explained, we have members of the audience who are going to be throwing problems for me to solve, other members of the audience with calculators, as well as people at home with calculators, who are going to verify that I'm doing these answers correctly. And I'm going to try and race them to the answer. First, we must make sure, of course, that the people up on stage know exactly how to use these calculators. Let me begin by asking someone, would you say a 2-digit number for me, please?
57.
57. Would you say a 2-digit number for me?
44.
44. Multiply 57 times 44 on the calculator. Make sure you get 2,508, or the calculators aren't working. What do you get? 2,508? 2508? 2508? 2508. Good. Okay. Now, calculators are actually very fast, but there are ways you may not know which can make the calculators work even faster. Let me show you. There's something called the square of a number, which is taking a number and multiplying it by itself. For instance, the square of 5 is 25. Now, the way we can square on most calculators, I don't think your computer will do this, Paul, but on all these calculators, if you enter a number, say 5, hit the multiplication sign, and then hit equals, you'll get the square of the number. This is a shortcut the calculators use to multiply even faster. What I will try and do now is to square 4 2-digit numbers in my head faster than they can do on the calculators, even using this shortcut method. So what I'm going to ask is each of you to call out a 2-digit number. You call out the first, you call out the second, you call out the third, and you call out the fourth. And if you would square the first, the second, the third, and the fourth, I will try and beat you to the answer. So if each of you would call out a 2-digit number, please.
63.
63.
97.
97.
57.
57.
88.
88. Would you call out your answers, please?
3969.
3969.
9409.
9409.
3249.
3249.
7744.
7744. Thank you. Let's go a few steps
Just
further.
a minute. 88 times 88. Yeah, well, I made a mistake. Okay, you beat me. Go on.
Okay, let's try some 3-digit numbers. To make it even more difficult on myself, I won't even write these down. I'll just try and say them right at you. Would you begin by giving us a 3-digit number, please?
273.
273 will give you 74,529. Check that out. Would you give me another 3-digit number?
324.
324 will give you 104,976. Good. Another 3-digit number.
738.
738 will give you 544,644. Good. And one last 3-digit number.
800.
800, 640,000. That wasn't even worth doing, but you blew your chance. You don't get any more numbers. That's it for you. Now, let's go one step further and try squaring a 4-digit number. Now, would each of you give me a single digit between 0 and 9? That'll be the 4-digit number that we use.
4.
4,
7.
7, 3, 5. 4735 will give you 22 million. 429,225.
Nope.
No. Let me try it once again. Ah, forgot to carry the 2. 22 million. But it ain't. 420,225.
Yes.
Yep.
Thank you very much. Now, thus far you've seen a lot of squaring mostly. You've seen 2-digit squares, 3-digit squares. You just saw 4-digit squares. Maybe you think there's something exceptionally easy about squaring. And the answer is there is. I mean, you only have to work with one number instead of 2 different numbers. When you bring 2 different numbers in there, it gets a lot more difficult in memory-wise. Let me try, and again, this will be even slower than the last problem, to multiply 2 distinct numbers so that I don't have to remember what the problem is, because that takes up a lot of memory space in itself. I'll ask you, please, to give me 2 of the numbers from the board, and I will multiply any 2 of these numbers together.
3,969
3969 times
7,744.
times 7,744. Okay. This will be the longest problem. 30 million. $735,936.
Yes.
Good. Thank you. Let's take a number we haven't used yet, 3249, and would all of you enter that on the calculators? 3,249. And instead of squaring it this time, I'd like you each, including you, Paul, to multiply this by any 3-digit number that you'd like. Is there any possible way that I could know exactly what 6-digit or 7-digit numbers you have? Say no. Good. Then I shall attempt the impossible, or at least the improbable. First, let me check out, do all of you have a 6-digit number or a 7-digit number in front of you?
6.
6 digits?
7.
7?
7.
7, Paul?
I've got 7.
7. 4 7-digit numbers and a 6-digit number. Would you call out 6 of your 7 digits, please?
166 488.
You must have left out the number 3.
That's right.
Good, thank you. That's 1. Would you call out 6 of your 7 digits, please?
138074.
You left out the number 4.
Correct, yeah.
That's 2. Would you call out 5 of your 6 digits, please?
76676.
You left out the number 4.
That's correct.
Good. That's 3. Would you call out 6 of your 7 digits, please?
575324.
You left out the number 1. That's 4. And finally, Paul, and don't give me trouble on this, call out 6 of your 7 digits in any order you'd like. You have a 7
In
digit
any
number?
order, yeah. Okay.
Absolutely any order.
63792.
I thought you were going to give me trouble. I think there are a couple of possibilities for this answer. Paul, do me a favor, and if you would, concentrate on your answer. Doesn't do a bit of good, of course, but it looks good on camera. No, Paul, I mean really concentrate. It seems at the moment that you're really thinking of nothing, and you must think of a number.
No, I am thinking of nothing.
Oh, you left out the 0 then?
Yeah.
Okay, well, that explains it. And let's give them a nice round of applause. Thank you all very much. Arthur, fantastic.
Thank you very much for coming on the show. Just in case you were thinking at home, let me repeat, no stooges, nobody knew what was going to happen. The other thing is we turned all the TV cameras and projectors and anything out of the way, so you got no tips from anyone at all. Ladies and gentlemen, Arthur Benjamin.